Hello, my name is Philippe Lyons, and I'm working in the product management department of Oracle Analytics. And today I want to spend a few minutes with you here to show you a demo of the value that Oracle Analytics AutoML can bring to you as a business user. So you can either simply watch this demo, or you can also use it as a workshop, hands-on lab, and reproduce it exactly at home with your own Oracle Analytics account or trial account. And you can reproduce it end to end or partially, up to you. So the agenda for the call today is going to have 6 different parts. First, we will connect to an Oracle database and use data that exists in all Oracle database as a source, and we'll briefly visualize this in OAC. Then we will use AutoML to design a machine learning model to predict a specific column. We will then visualize the results, the parameters of the model, and the metadata of the model. We will come back to this and generate a second version of the model to predict the same variable. But in that iteration, we will enrich the input data ourselves. And then eventually we will use the model that we have created to score our data and generate some lift information. We will visualize the results, we will visualize the scores, as well as the quality of the model, and compare lift results for multiple models. And we will do all of this as business users without any skills in coding or machine learning or SQL or anything like this. So let's get started. So this is my Oracle Analytics homepage. This is where I land when I log in into the Oracle Analytics service or the Oracle Analytics server. I can see my workbooks, data sets that I have access to. So let's start by visiting the connections we have in this Oracle Analytics environment. So the lab requires a connection to an ADW or an Oracle database. And I have one here that is connecting to an ADW using dev user username. So let's remember that name, we will use it later on. And dev user is a database user that has access to AutoML capabilities in the database. So you can reproduce this lab with any ADW users you pick as long as he has access to AutoML in ADW or in the database. Now let's go and create a data set using the data that sits in the database. So there are samples, schemas that come with any Oracle database. One of them is called SH, sales history. So that schema is present in most of the Oracle databases. So here, this is what we're going to use for our workshop. And we're going to create a data model made up of 2 tables, customer and supplementary demographics. I just drag these 2 tables and automatically OAC recognizes that they should be joined via a column called customer ID. The join in this case is of type inner. I could override this, and I could also fix the columns of the joins or create more columns in that same join. For now, I'm going to leave it like this as it was the right guess by Oracle Analytics. The thumbnail charts give me already an appreciation of the data that I have connected to. I can look at each table separately. I can use different ways of looking at the table. And let us look at the supplementary demographics table in particular. Here we can see the different columns that this dataset contains. There are extra attributes about customer profile, and we can see that some are treated as attributes, some are treated as measures, but functionally what they really are, they are attributes. Years of residence, affinity card, flat panel monitor, yes or no. These happens to be numbers in the data set, but really they are Boolean yes, no type of answers. So let's select all of them, mark them, treat as attributes, and set them as data type text. So that will be the extent of our data preparation for the hands-on lab. So we save this data set, give it a name. Let me call this hands-on lab demographics. That's the name of my data set. As we go back to our homepage, we now see the hands-on lab demographics data model, and we can start using it. So let me right away create a workbook with this. So on the right of the screen, we can see automatic charts coming up on this new data set, but I'm going to close it today. We're not going to use it. And on the left, I see the 2 tables that make up this data model. So I can right away start visualizing data, or if I click on explain, I will get some descriptive charts here, which I can select and add to my canvas. This is showing me that there are about 56,000 records in customers table, broken down in this case by different values of customer marital status. I can do the same with any other column, and in particular columns from the other table, supplementary demographics. Let me take affinity card. This is the breakdown of affinity card values, 1 for yes, 0 for no. So we have about 24% records that have an affinity card, and only 5,000 records here belong to supplementary demographics. So there are only 5,000 records for which we have extra profile information out of 56,000 that we had in the customer table. So in this workshop, we will take the example of affinity card and build a predictive model that predicts the probability of every single customer to sign up for an affinity card or not. So we need to build this predictive model. And we are going to use this data set as a training data set for our model. So for information and for understanding the data, I prepared a canvas here breaking down affinity card records by different dimensions. So you can see at the top household size, marital status, years residence, and the orange part is the proportion of records that have an affinity card. There is no need for you to reproduce this canvas as part of the workshop, as this is only showing how the data that we've connected to looks like, and you've connected to the same SH data as the one I have here. So this data is rich and dense enough that it's going to be decent training data for us to build a model. However, I'm not familiar with machine learning and I can't really build a model. I'm a business user. I understand my data, but I don't have the technical skills to train a machine learning model. I wouldn't know how to select the right algorithm. I wouldn't know how to select the right columns to feed into the algorithm, nor would I know how to tune the parameters of the algorithms to get the best result, to design a quality model to predict the probability of affinity card per user. So that's where the AutoML capability of Oracle Analytics is going to turn extremely valuable for me, business user, because it's going to let me define and design very accurate machine learning models without requiring any coding or technical skills on my side. So let us go and use this feature. And for this, we're going to create a data flow in Oracle Analytics. So here we're selecting the training data, the data that we were looking at with the history information about affinity cards, so HOL demographics. And we can select columns here, but instead of selecting one by one, I'm going to select all the columns in this data model. If you remember, we had two tables, customer and customer supplementary demographics. So here are the columns that we're going to feed this process with. And of course, one of these columns has the affinity card. The next step is to go and invoke AutoML. So here, among the different nodes that I can call out, I could manually train different models here. But as I said, I'm not technically skilled, so I'm going to click on the AutoML capability here. Notice that this node is active because my dataset sits on an Oracle database. The AutoML technology we're using here resides in the database. It's the OML AutoML technology. So that node will not be visible if your data source in the data flow is not sitting in an Oracle database. So I just clicked on the node here, and all I have to provide is which column do we want the model to predict. So in our case, it is affinity card. It is a column of type text. We can see the little AB next to the name. And if you remember, we changed this in the data prepare. We made it a text. And because of that, the data flow is guessing that we want to train a classification model, a model that will predict which of many classes each record is most likely to fall into. This is by opposition to a regression model, which predicts a value, a number. In our case, we're predicting a class. The data flow defaulted this for me based on the data type of the column that we want to predict. So we could override it if we wanted to, but in our case, this is the right choice. The second dropdown here is offering us to select the model ranking metric. So this is not mandatory. We can very well leave the default and the data flow will work. But for the purpose of this workshop, let us still take a minute and look at what this is about and why and when it is important. When we will run our data flow, the system here behind the scenes will use our data to train many machine learning models at once with different algorithms, and it will only select one as being the most accurate and present us only with that selection. In order to do this, it needs a model quality metric to compare models by and select the best one. And that's the model ranking metric here. So there are different matrices that can apply to different specific use cases, basically depending on the data that we want to predict and how it is shaped. So the dropdown here offers a choice of many matrices to pick from. And if you hover over each of them, you will see a tooltip describing in business words why and when you should use a metric versus another one, depending on how your data is distributed. So it should be fairly easy for me as a business user to understand that I should pick one versus another. As far as the workshop is concerned, I'm going to pick F1 weighted just to pick something here, but you can very well leave it to default or pick something else, and your process will most likely result in a different machine learning model than mine. As a matter of fact, we will iterate on that metric later on in the workshop. So that's it, we're done. We've configured everything we needed to configure. All we have left to do here is to give a name for the machine learning model that will be generated by AutoML and registered in OAC, and run the data flow. So we also need to give a name to the data flow. And while we hit OK, this is going to trigger the process underneath in the database. So exactly what is going on here is a sequence of steps in the database called the AutoML pipeline, where the machine learning engine from the database uses the context of what we have just entered and first identifies what algorithms can contribute to designing the best model for that context, does a custom adaptive sampling on the data that we have, then introspects the data and does the best column selection that can contribute to the model quality. So these are called features, and eventually tunes parameters of different algorithms to produce multiple versions of possible models and ranks them according to the model ranking metric to deliver only the one that has the highest quality. So this is all happening behind the scenes in our database as we've kicked off this data flow. But unfortunately, in our case, this first trial is failing. So let's look at the details here. And in the middle of the text with the error message, we will find that the database type date is not yet supported by OML, AutoML. So the database doesn't accept dates as input text. So we'll see how to work around this in a few minutes, but for now, let's simply go back to the source data and simply unflag the two columns that hold a date data type. So these are customer effective from and customer effective to. These are a date data type in the database. And while we are there, we can just as well remove a few columns that we suspect are not going to add any value into any models, such as customer ID or comments. Comments are just plain text. So it's just that easy. By unflagging these columns, AutoML and OML will not consider them as potential candidates to participate into model. So we will see more options later on in the workshop on how to remove column and add calculated columns. But for now, let me simply save and run the data flow just with these changes. So now the whole process is kicking off again behind the scenes in the database, what I described a few minutes ago, and the data flow completes successfully. So at this point, a machine learning model was created in a database, the best one for our request. So let me just visit my data flow to give you a sense of the time this took on my side. So if I go to inspect on my data flow, look up history, I can see that the data flow ran for 2 minutes and 20 seconds. The previous run was the one that failed, where we had the date issue. So now we're all curious to see what model we have generated here. So the process has registered the model in OAC as well. So if I go to machine learning here, I can see the model we just generated. If I click on inspect, we can see now what this model is about. So first of all, we have general information about the connection and what column it is predicting. But if I navigate to details, then I can see what algorithm got selected as the best model. In this case, it is SVM, support vector machine. And it's telling me as well that feature that ended up being selected for this model are these columns here. So from all the columns in our data set, these were the ones that eventually qualified as influential in this model. And eventually at the bottom here, I can see all the parameters for this algorithm, which is the technical part of the tuning for the machine learning model. If I navigate to another tab now, which is called Related, this is going to show me where I can find some metadata and quality information about that exact machine learning model. So what I see in these tabs are database view names that got created on the fly when the model got generated and that contain different type of data. You can see the topic in the middle about that exact model. For instance, the DM$VL view holds the SVM linear coefficient for this model. So if I look at the data in this view, I will be able to visualize to which level each feature contributes to that model. So let's do that. $VL, and the model name is the name of the database view. So we're going to create a data set here, go to the same database, look at the schemas, and if you remember, the schema that we're using here is the schema of the user where we had the connection, which was dev user. That's what I showed you at the beginning of the video. So in that dev user schema, let's look for VL view. So there's only one because we only had one model created at this point. $VL view with the model name that we have. So the more models we will create, the many version of this view we will have. So here is the data. So we can see the different columns contained in that view. And for the matrices, we just need to fix this so that the aggregation is not sum. We don't want to sum the coefficients. We want to average them. So all we have to do is fix this to average. And there we go. We can save the data set in OAC. So it's a coefficient data set about this model. And if we create a workbook now, we can visualize the information about the model we just created. So if I just take attribute name and coefficient value, create best visualization, I'm going to get a bar chart with the big bar on the right showing the null values. So let me just put a filter on attribute for excluding null value attributes. So now we see all the coefficients with the different columns. Let me turn this into a stacked horizontal bar chart. It's more readable. Let's sort this by decreasing value of the coefficient. And let's just remove the ones in the middle that have a very small coefficient. So now we're left with a bar chart that's showing us all the different columns that contribute to the model with their coefficient. So we can appreciate that years of residence or customer year of birth or credit limit are influential in the model and get a functional sense of that model that we just generated with AutoML feature. So at this point, we can consider that we are done. Even without any skills in building machine learning models, we have leveraged the AutoML feature to design a very accurate model to predict affinity card. So we could go right ahead and apply it. And we will do this in a few minutes. But before that, let's loop once more through the process so we see a few more options and we're able to compare models eventually. And to do that, let's simply reopen the data flow that we created a few minutes ago. And we're going to rerun it. But before that, we will change a few configuration in it. So here is our data flow. So let's now pretend that we want to enrich and increase the number of columns that participated into the AutoML process so we make the model more accurate possibly. So let's say that we want to bring back some date information that we eliminated earlier on and have more input to the machine learning with calculating, for instance, the year of the date that the customer joined the organization. So we are going to add a column, call it year created, and use some calculation functions here, just year, extracted from the customer effective date, which is the regular column of the data set. So I just pick it, and I can calculate any additional columns or measures to feed the AutoML process with more and more information to make the model more accurate. So for instance, here, let's pick another one. Let's calculate age of the customer by subtracting the year of birth from 2023, which is this current year. So we can easily go on and enrich the input data set with business meaningful objects and calculations. We can join data sets. We can do all sorts of transformations here. But what I'm going to do here is simply use a select columns step to remove a few more columns that I think may not be meaningful, such as customer email or some technical columns. And I will also remove the customer effective date, which is of data type date. And if you recall, that would create an error with the AutoML process. So now that we have calculated year, we can remove that date from our input. So we are done with our simple edits. We just need to make sure we give a new name to the model that will be generated by the new run. And we simply rerun the same data flow. It will generate a new optimized model using the new input. So again, we could have done all sorts of transformation and enrichments here upstream of the AutoML node. This is fairly easy for me as a business user to do, and it will likely help the AutoML process design an even more accurate model behind the scenes. So this is running for about 2 minutes behind the scenes. So if I fast forward to the data flow history, you can see that again, with this change, it ran for a little longer than 2 minutes. So let's go and check the new model that was generated, move to the model category here, and we should see our model 2. If we look at the inspect menu in the details tab, we see that the algorithm selected was different. So the best model here is a random forest. The input columns are different. We can see that age, which is a calculated column, contributes to the most influential parameters here. So that's a column that we created. And then if we check the parameters, we will see that there are also different parameters that have been set for that model, just like we saw earlier on with the SVM first model. So at this point in the workshop, we have generated 2 machine learning models to predict affinity card, and each of these models was optimized according to a specific set of input data. So natural columns for the first one, and enrichments as well for the second one. And both these models have their accuracy optimized according to these distinct data sets. And the interesting part is that we did this without any machine learning skill ourselves, without even having to pick an algorithm or tuning anything about these models. So if we had tried to do this and tune these models manually, it would have taken us a lot long and a lot more experience and understanding of machine learning. But the AutoML feature here made this a lot simpler for us. So in the last part of this workshop, we're now going to consume these models. We're going to apply them against our own data and compare the results and the accuracy of these models visually and visualize the data. So for this, we're going to go back to our home page and create data flow. So data flow to apply machine learning model. So we need to use a data set to apply against. And in our case, we are going to use the same data set as the training data sets. We are going to predict the probability of affinity cards on a data set where we already know that customers have or have not an affinity card. This will allow us to see how well the model is doing against the data that was used for training it. Let's select all the columns in that data set like we did earlier by clicking on the folder tick mark here. Here's our data. And we're going to now add a node to the data flow, which is the apply model node. That apply model node is a common node for all types of model in Oracle Analytics, including models that were generated by AutoML. So same experience for people consuming the model. We just have to select which model we want to apply to our data among the different choices. In our case, we're going to pick one of the models that we just generated with AutoML. There are a few interesting options among the parameters of apply model node. Let's take a minute to see what they're used for. So first, input columns. On the left, we see all the input columns necessary to the model. And on the right, we see what columns in our dataset has been mapped to each of these columns. The system was smart enough to recognize that which column in our dataset best matched the expected column as an input to the model. We can obviously override this manually by clicking a different column, but we're not going to do any of this in our case since the defaults are all correct. Then the outputs. So outputs will provide with the prediction and the prediction probability. That's a classic output of machine learning model. But with OAC and OML, there is a lot more value to extract under additional outputs. So there are many more columns that users can select from. So first at the top here, we see prediction 2 and probability 2 and prediction 3 and probability 3. So we want the main output to be the most probable prediction, but we may also be interested in having the probability of the second best prediction. So if a customer is predicted to belong to a group with a probability of 51%, we may be interested in knowing what was the next probable group that the customer was likely to belong to, and so on. So we would get this information by clicking on these columns. In our case, since it's a yes or no prediction, just one output is enough. Scrolling further down to the bottom of the list here, showing us set of columns attribute 1 weight, and attribute 1 condition. Same for attribute 2, attribute 3, 4, 5. These output columns are extremely valuable for us business users because they will give for each record what attribute contributed to the prediction for that record. So that's attribute 1 with its weight, and the condition is what is the value of that attribute. Then second most important attribute, its weight and its value, and then third and fourth and fifth. So this is different from model metadata explaining most influential attributes in the model. This is at the level of each record. Which of these attributes contributed to the specific result for the specific record? Let us select attribute 1, 2, and 3 for our example here and carry on. I'd like to also spend a minute on the parameters section here. In the case of classification models, that's our case here, OAC offers the option to compute lift and gain measurements. That is true only for classification model and requires to have a data set where the actual data exists, not just the prediction. So let us select this and say yes, and then we're going to have to provide with a column that holds the actual value. And the purpose of this principle of lift and gain is to be able to measure how much benefit we will gain by leveraging the model instead of randomly assigning classes to records. So we need to provide also the value of the positive class. So yes, affinity card, that's 1. And that's it. So OAC will compute lift. So we're done with parameters and outputs here for applying our model. All we have to do now is to save and run this data flow. So we need to give a name to the data set that will hold the scoring results and give it a name in the database as a table as well. And of course, in the output, I need to pay attention to the aggregation rules that are set. So for probabilities, I need this to be average. And for some IDs, I may want to make this be an attribute as opposed to any metric. Let's give a name to the data flow as well, and let's run it. And as we hit run, the work is happening in the database here because the data is in the database and the model is in the database. So the Oracle database computes the scoring over the records and returns rapidly two data sets with all the outputs results. So in this case, because we've asked for lift calculation, it will return two distinct data sets. So one holding the lift information and another one holding the scoring information and the details. So in this one, let me first create a calculation to simply count rows. So I'm counting customer IDs here, just a simple calculation. And let's bring this calculation into the canvas, create best visualization. And that's 4,500 records. That's the count of the supplementary demographic table. Let's look at the breakdown by prediction. So we have so many predicted zeros and predicted ones. Let me show this as a pivot table and add a sum of rows. And I'm going to add another column to this pivot table, which is the actual value of affinity card, and drag the affinity card as a column here in my pivot table. Now let me briefly add a sum of the columns, and now we have a confusion matrix for this model. So we can see true positives, true negatives, false positive, and all the ratios here that we can calculate about the quality of this classification. So let me Control-C and Control-V to duplicate that same V's. And in one of these, I'm going to navigate to numbers and display values as percent of total. So now I see percentages for the confusion matrix, and that's a lot more intuitive and easy to understand. So now let us open a new canvas and visualize a comparison of actual values versus predicted values by a given dimension. So let us take affinity card and years of residence and show it as a stacked bar chart here. And have one that represents the actual values, numbers, and the other one at the bottom representing the percent. So yellow here is the records that have an affinity card broken down by years of residence, and the chart at the bottom is showing the percentage portion of records with an affinity card. Now let's try to reproduce the exact same two charts on the right of the screen, but instead of the actual value, we will have the predicted value. So I'm simply dragging the prediction attribute over the affinity card, the attribute that we have in the visualization, and we're able to compare how well the model predicted affinity card compared to the reality. So in this case, by this dimension breakdown, it's a pretty accurate prediction, as you can see. So we could repeat this with various dimensions and get a sense of how accurate the model is across different dimensions. For example, here I'm dragging education to replace years of residence, and now I can compare the same prediction across this dimension. Now let's create another blank canvas and leverage the attribute that contributes to the prediction. So I'm going to select customer ID and create a table with every single customer ID, bring in prediction and prediction probability, keep this be a table, and I will drag prediction as a color so we have a better sense of what is yes, what is no. And now let me bring the attribute, weight, and condition for attributes 1, 2, 3. So let me make the screen a little wider. This is telling me for any record that, in this case, for instance, this one predicted 0, because household size being value of 2, and that influences at 54% the decision, and occupation being value professional has an impact of minus 21% or minus 21 ponderation. So that detailed data helps me to understand for every single record why he was predicted like this, and hence it will allow me to explain the results to begin with, and second, to take precise business action to that prediction. So that's very powerful. That comes down to explainability of the model results for me as a business user. Finally, let us build one last visualization about our results here, and let's invoke the lift dataset that we generated. So that's a separate dataset. We can bring it into the workbook just by adding it. And here's our lift. So that dataset has 100 records. It's 1 record per percentile. So if I click on percentile, here's our list. And I'm going to drag the gain chart baseline and make this viz become a line. The x-axis is the proportion of the total records, and the y-axis is the proportion of the positive records. So this is simply telling me that if I go and pick records randomly, by the time I have reached 100% of my data set, of course, I will have picked 100% of my positives. And that random proportion applies at any point in my random pick. Now, suppose that instead of picking records randomly, we pick them according to the prediction probability for a positive case that we got with our model. You would expect that we would pick positive cases a lot quicker than if we go random, right? And that's what the cumulative gain that we've calculated measures. So if I drag cumulative gain here, that black line indicates that if we go with a low proportion of records, we will get a higher proportion of positive cases on the y-axis. So it's not a straight line, and it has different other calculations such as optimal gain point, which indicates the point from which the benefit of using the model starts to decrease, the lift value calculation itself as well, which is the ratio of how faster we're going at the beginning of the curve compared to random. So these are all calculated by the lift option that we invoked in the data flow. And in fact, I did run this for another model as well that I had done, the model number 2, and we can easily compare multiple models next to each other. So just bringing in the other lift data set, it automatically joins with the first one. And I can simply drag the other cumulative curve, and here I can compare my 2 models, and depending on how many records I want to reach to, select which one has the higher benefit for me. Now I see this as really powerful and both cool at the same time. So we're reaching the end of the workshop here, and I wanted to briefly recap. So we started with some data set that exists in an Oracle database, and we were able to rapidly define best-in-class machine learning models to predict a field in these tables. We were able to actually prepare some of the data and enrich it in a data flow. And then we looked at some quality metrics of these models that we have produced. Then we applied the models on some business data, so scored business data with these models. And as we did this, we invoked different outputs such as explainability outputs, but also quality and lift measurement outputs very easily. I am hoping that the business value we could have extracted from this was visible pretty much all along the process here. And I want to attract your attention that we did all this without any specific machine learning skills or coding skills or SQL skills. All we did here was use OAC in a pretty simple way. Hopefully you enjoyed it, and all I have left to do is to thank you for your patience listening to my Frenchy English, and hopefully we'll connect again soon. Thank you very much.